Hi there. In today's video, we'll be going through a summary of grade 11 analytical geometry, which is also essential for grade 12s. All right. So to begin, we are looking at the equation of calculating the average gradient. This is important when you are asked to calculate the equation of a line. So that's when you need to know what your gradient is. And that is actually just the difference between the y values divided by the difference between your x values. Moving on is the distance formula. So if we've been asked how long a line is, that is when we need to apply the distance formula. So we are looking at the difference between the y's squared plus the difference between the x values squared, and then you get a square root of everything, and that's the distance. And then next is the midpoint formula. So this is when you've been given two coordinates and then you've been asked to find the midpoint, which is the coordinate of that point in between those 2 points. So in this example here, that midpoint is t. So to get the coordinates of t, it would be the average of the x values divided by 2, and also you get the average of the y values. So that's the midpoint formula. Next is the angle of inclination. So understanding what the angle of inclination is very essential, because you also use this to calculate the gradient. So you can calculate the gradient using two methods. The first is with the angle of inclination with tan theta, or you can use the equation we looked at in the beginning, which is the difference between the x and the y values. So what is the angle of inclination? It is this angle over here that is formed between your x-axis and your line. That is the angle of inclination, and it is, if your gradient is positive, meaning it's greater than 0, then your angle of inclination will be acute, meaning that it will be less than 90 degrees. On the right here, we have an example where your gradient for your line is negative. So with a negative gradient, you find that that angle of inclination is much wider. But we always measure the angle of inclination from the right hand. So that is the 0 degrees over there in the first quadrant. So even now, when you now have a negative gradient, we still do measure it starting over there at 0 degrees. So it will be from here all the way up until you touch your line. You do not make your angle of inclination this one over here, which is from the left going towards the right, because that is incorrect. You can still use that one. However, when you then want to calculate your gradient, the theta that you will be using will be 180 degrees minus that theta. That's then the angle that you use, because as you can see, with a negative gradient, you get a much wider angle. So if you see that you are working with this one, when you are substituting in the formula for the gradient, just remember to use 180 degrees minus that other angle that you used. All right, so that's the angle of inclination. Next is the equation of a circle. So you get to expand on equations of circles in analytical geometry for grade 12. But in grade 11, the key thing that you need to know is that the equation of a circle is x squared plus y squared being equal to r squared. And that's the equation of a circle when the center is at the origin. So that it means that when we look at the true equation of a circle in grade 12, we are actually looking at it where this A and that B are equal to 0. So those are your coordinates for the center of the circle. So if the center is at 0, 0, it means that when you substitute A and B, they become 0, so you end up with this equation. Okay, that's it for the equation of a circle. Next is looking at the equation of a straight line. So when it comes to calculating the equation of a straight line, there are two methods. So the first one is the one most people prefer, which is this one. And then there is that other one over there. So with this one, you also need the gradient. However, it's actually much faster to work with this equation because all you need to do is to substitute 1 point, and then you don't have to manually calculate C. The equation already gives you the value of C. So all you're substituting is a point, and you substitute the y and the x coordinate of that. And then you leave the y and the x without the subscript as they are. So all you're substituting is m, x1, and y1, and the equation will give you a C value. Okay, then we have equation of a horizontal line. So this actually tends to get most students confused. So when you just have a horizontal line, it means that it just has one y value, but the x values can change. So looking at what we have over here, we find that we are at y is equal to 3, and then we have a horizontal line. So that means the equation of this straight line that is horizontal will be y is equal to k, which with k being the y value that is constant, and in this example it's 3. So whenever they ask you for an equation of a horizontal line, look at what is that constant y value, and that then becomes your equation. So here it's y is equal to 3. And then moving on to vertical lines. So with vertical lines, the x value is constant, but the y values are varying. So for example, if we were to look here, let's say this is at y is 4. The coordinates there will be 2 and 4 for this point over here. And here on the one that cuts at the x-axis, those coordinates will be 2 and 0. So 2 is what is constant, which is the x value, but the y values are varying. So the equation of a vertical line will be the value of the x value. So in this scenario, it's 2. So the equation of this vertical line is x is equal to 2. And then we also have to look at perpendicular lines. So when you multiply the gradients of two perpendicular lines, they give you a product that is -1. So you'll find that in exam questions, you'll be given the gradient of one line, and then they'll ask you to determine the gradient of another line that is perpendicular to that. So using this example, let's assume that we have been given the gradient of line CD, which is this one over here. So for us to get the gradient of MAB, we just need to make that the subject of the formula, meaning that the gradient of MAB will be equal to -1 divided by the gradient of CD. And that's how you get the gradient of one using the other. Okay, and then lastly, we are looking at parallel lines. So whenever you are told that two lines are parallel, you should be very happy, because it means that they have equal gradients. So if you have the gradient of one line, you don't need to calculate the gradient of the other line that is parallel to it, because they are equal. All right, so that is it for the summary of analytical geometry. They are really easy concepts. You just need to do more practice questions so that you can see how to apply them in different scenarios. Okay, bye.